Alright, so we're going to start here by creating a new user. So we can click 1 to create a new user, and then the camera is going to come up. And what this is doing is it's adding me into the database right here. So the image is uploaded to the database, and then I can verify myself by clicking 2. And then here, the image is uploading, and it recognizes me, so it says welcome user. Okay, so click 2.
2?
Yep, and then enter. And so here, it is going to recognize Beatrice as an unknown user, right there. So the next user that we're going to try is Justin, and he is going to try to verify himself on the camera. So we're going to go to verify user here, and then it looks at Justin, and then it's uploading the image to the database, and it shows here that Justin is an unknown user.
Okay, so here's a bit of a rundown of what we got so far. Here we have our main menu. This is a simple user interface where we can create a user or verify user. Verify user is just basically attempt to sign in. Here we've create user. This is the first real method. We set up the Pi camera, which takes a picture, saves it with a name, a unique name, such that there's no overlap. We don't lose any files with the JPEG file format, because that's the only image file format that Waya seems to like. This is where we call in Waya. Now this little token here, this is very important for the space, which is this whole thing, this whole page on Waya. You can register a device, and this token has to match up with the token of a registered device on that space for it to work. Otherwise, this whole thing just wouldn't work. This then triggers an event, the user event on Waya, which is this event here, where the image is passed up into the AWS software to detect and recognize faces, which generates a lot of data to do with the face in the image. That data is then passed into this run function method, inside which we have some JavaScript which will filter out the data we don't want, and filter the landmarks, which is the data we're using for this project, which will filter the landmarks into an array, which we push up to MLab via the send webhook method. Which gets passed up to here. This the users one. These are both these databases are empty for now, just for testing purposes. And then we get to verify user. This is identical to create user, except for this line here at the end. It triggers this event, an image event, as opposed to the user event, which it follows the same flow. Except this time it ends up in a different database. So you have a database for users and a database for sign-in attempts, which will be cleared after every sign-in attempt. Then of course we've got this line here, which is the Euclidean distance formula, or method, which takes in the output from retrieve user and retrieve image. Retrieve user just gets the data from the user MLabs. It gets the data back from here and formats it into a nice manageable array of floats. This line here, this is quite important because this allows us to only take in, this removes everything beyond the first 18 figures in the array. This is because WASN tends to duplicate, if not quadruple or triple, the data when you use this for WASN webhook. It tends to send multiple instances of the data up to MLab, which can be quite a problem and will affect the final result. So there's 18 figures in the array per image, So we filter and just get the first 18. That way there's no duplicates, and we've the correct data, and it works out. Retrieve image is the exact same, except it goes into the other database and gets image data as opposed to user data. And then the Euclidean distance method, this takes in both those arrays, and A is user and B is image. Distance is the Euclidean distance of A minus the Euclidean distance of B, and if that distance is less than 0.3 and greater than minus 0.3, excuse me, we are accepted as a known user, as the known user. Whereas if it's not within that range, we are not a user. At the moment, this is what we have. We don't have it triggering an actuator as of right now, but that is the plan, such as to simulate the locking and unlocking of a car door.